Now, the corresponding term corresponding to the stress, the term is strain. Strain is basically the effect of that particular kind of a stress. Means when we apply the loading, when we apply the deforming force, then we know that it basically generates a kind of a stress in the body, and its effect is strain. For example, in case of, if we talk about the longitudinal stress, then we know that it will cause the change in the length of the rod. And when we talk about the shear stress, then we know that it will change the angle of this surface. And when we apply volume stress, then we know that there is corresponding change in volume as a effect. So fractional change in that property is known as the strain. Change in that property divided by the original. For example, we have got a rod of length L, and suppose by applying forces on its both ends, we have changed its length from L to L plus delta L. Then its strain is delta L divided by L. That means it has no unit. So this is change in length divided by original length. And in the same way, here you can see change in volume divided by the original volume. And here this particular angle theta is basically the effect. Suppose upper edge is moved further by x and h is the height, then this angle theta is roughly x upon h. So this is our strain. So that means depending on the type of the stress, we can define the strains. Corresponding to each type of stress, we have got one corresponding strain. For example, longitudinal strain. So longitudinal strain means change in length divided by original length of the rod or the wire. Suppose we have a fixed support from which we are hanging a metal wire, and suppose a weight is being suspended through this wire, then we know that tension is there all over this particular wire. So because of this, its length will increase. So this is the situation of longitudinal stress. So corresponding strain will be the longitudinal strain. So change in length divided by the original length of the body is longitudinal strain. And here the reverse situation can also be there. It may be a case of compression also. In that case, delta L will be the decrease in the length in that case. So whatever change divided by the original, it is the strain. It has got no unit. And similarly, the shear strain, as I have already explained, this particular angle phi which the object is turned through is known as the shear strain. Suppose F is the force and this edge is moved further by an amount x, and this is L is the height, then this angle phi or the tan phi you can see for the time being x upon L. And since in case of solids this angle phi is not going to be very large, so it will be roughly equal to phi also. So tan phi will be approximately phi, and which is equal to x upon L. L is the height, this one, and x is the displacement of this point, because on applying this shear force, this point will be moved here by distance x. So x by L is shear strain. So it is defined as the angle theta through which a face originally perpendicular to the fixed face is turned. And the third kind of a strain is the volume strain, which is clearly delta V upon V. If we apply the bulk stress on a body and suppose there is a corresponding change of volume delta V, then delta V upon V, change in volume divided by the original volume, is basically the volume strain. So this is corresponding to the volume stress as we defined earlier. So in this session, whatever we have learned so far are the just few definitions, and using these definitions only we'll be solving one or two examples, and then we'll move to the next session to look into deeper in the same topic.